This is 7.4, integration by parts. First, I want you to recall finding the derivative of functions that look like this. Okay, it's going to be first times the derivative of the second plus derivative of the first times the second. So if I give you this f prime and I ask you to take the antiderivative, you know what it is. So how do we formalize this? Well, first I want you to try a couple, just get it into your head how this works. If I give you sine of x and cosine of x, sine and cosine of x can usually go either way. Let's see. So I'm looking for something that's something else's derivative. Derivative of sine is cosine, so I kind of think of this. Derivative of x cubed is 3x squared. So I just use sine of x and x cubed. Okay, so I'll try another one. So let's say I give you this problem, then what you should see is, well, derivative of x squared is 2x, and derivative of 2x is over here. Okay, so then f is just going to be x squared times 2 to the x. No big deal. Okay, so now we're just going to formalize this. And in class we talked about why that's true, because if you just go with the chain rule, sorry, the product rule, and then you integrate each piece, eventually that's where you end up. Okay? I'm not going to do that on the video, but you know how to do that if you want to. And I also said in class what's more convenient is you usually put the polynomial on the u part, but in the case of natural log, well, sometimes you don't. Okay, so how do you use this? If we have the problem x sine of x, we did that one first. Then we might say u is equal to something and v prime equals something. We have to use up all our pieces. The thing we like to take the derivative of goes on the u, and everything else goes on v prime. Right, taking the derivative should be easy. Antiderivative. Problem is, don't forget the sign. Okay, then you got to match these guys up right here. So we go ahead and do that. Minus x cosine of x and minus. So people ask me why a minus. Well, you have to understand the derivation if you want to know why there's a minus. If you don't care why there's a minus, you can just use it. And then we go ahead and put, let's see, these pieces together. Alright, and that is the one you don't really see. The minus comes out here and annihilates that minus sign. So then we have to finish up the problem. Okay, that should be pretty straightforward. Alright. And I did in class what happens if you mess up. Well, if you messed up and say you said u is equal to sine of x and v, like you did it backwards, let's say, I won't go through the whole thing, but if we mess up, then you'll start with a problem like x sine x dx, and you're going to go through the whole process, and what you'll end up with is x squared sine x over 2 minus integral x squared over 2 cosine x dx. And what you see is this guy kind of looks like it became that guy. You got messier. So it's not like you did anything wrong, but it's just useless. Okay, so let's try another one. So if you're watching this on a video, you should try this yourself and then come back and make sure you agree with everything I'm doing. Okay, I'm going to put u as just t, v prime is everything else, and then u prime is 1. E to the 5t is its own derivative, its own integral. You only have to worry about whether it's kicking out a 5 or a 1/5. If you're taking a derivative, it would kick out a 5, but we're integrating so it kicks out a 1/5. Okay, we assemble all these pieces. First we do this way. And that 1/5 can go inside or outside, it doesn't matter. And so we just finish up this problem. When we take this integral of e to the 5t, we're going to kick out yet another 1/5. So you're going to get this nice progression here. 1/5 and then it's square, 1/25. Okay. We'll try the next one. Alright, we don't like the z's unless they're crossed, and we still don't really like them, but that's the problem we did in class, and I'll do it again. Okay, so if you wanted to, you could split this up into 2. You could go z e to the 2z, and then plus another one, e to the 2z, and that's totally fine. It's just, it's not the fastest way to do it. Okay, so I'm going to say u is equal to z plus 1, v prime is everything else, and again, e to the 2z is itself. It just kicks out something. What does it kick out? It's a 1/2. Match these pieces up. Just be careful that you don't lose them. Make sure the z plus 1 stays as a group. And then you go that direction. Then we just have to worry about finishing the problem correctly. And that's just your usual calculus. And don't forget your plus c. I've probably been forgetting. No, I haven't been. Sometimes I forget the plus c's. Like way up at the top, I was forgetting the plus c's. Here, aha! There, I forgot them. See? Bad. Should remember that. Maybe you just put it in the formula right there and then you won't forget it. Okay. Let's see, was there another one in here? Oh, yeah, a couple more. We had this guy. Yeah, okay, so you asked me in class why u's and v's are used together. I have to just be very, very careful when I'm using them. Alright? Elephant prime over elephant. Elephant prime is 1. What about v prime? Okay, so increase the power, new coefficient, great. Put these pieces together, what do you get? Bippity boppity boo. Okay, this pairing is just going to take an x out of this expression. This is why Matt likes this. If you don't know who Matt is the SI leader who is currently, let's see, currently we're talking about fall of 2013, and Matt loves these problems. So shout out to Matt. Okay, so we get natural log x over 4, and then what do we do? Okay, x over here is cubed, so it becomes x to the 4th. So it's going to kick out a 4th. It's going to come join down here and make this a 16th. And so, yeah, see, this is something you should learn to expect. When you're doing integration by parts, you see a 1/4 here and a 1/16. It's very, very common that you're going to get some number and then the square of that number. So it's either going to be in the denominator or numerator or whatever. Doesn't matter. Okay. Now, special fun. What about this guy? Why is this special fun? Well, shouldn't u be t squared and v prime is everything else? Sure, of course. Of course. No big deal. This is the same old we've been doing. So we go ahead and do this, and we do t squared over 5 e to the 5t minus integral of the other stuff to t over 5 e to the, uh-oh, what happened? what happened is, not a big deal, but we have to do integration by parts again, unless we happen to have on hand some memory of this particular problem. And I think we do, right? So, did we do TE to the 5t already? I'm going to look back in our notes. Let me see if we have it. I think we did it. Aha, here we do. So, it's somewhere up here. There we do. We have this. So I'm actually just, because I'm on a computer, I can just go copy. Okay, I'm definitely just going to copy that and bring it down here. Here we are. Nope, further down. Further down. Where are we? Ah, here we are. So now I'm going to rewrite this. And then I'm going to paste. I'm going to change the color so you know the stuff that is pasted in I just pulled from up above. There we go. That plus C I can just stick outside. We need another one over here anyway. There, we're done. That's really all there is to it. Oh yeah, I know. In class I finished this. Okay, so I'm going to pull out e to the 5t and divide by 5 out of everybody. So I'm going to get rid of this guy, and this guy, and this guy, and this guy, and that guy. So then what I'm left with is t squared 2t over 5 minus 1 over 25. There we go. That's it. Hopefully that's right.